Okay, so in this video, we're going to look at an osmosis exam question. We're going to put in some of the knowledge we've learned about osmosis into an exam situation. So first off, what we have, a student has done an investigation and they've looked at the surface area of a potato cube and the effect it has on osmosis. So the student cut 2 cubes of potato, each with size 35 millimeters long. They made 2 cubes. They then took one of those cubes and they put it into a sugar solution. They took the second cube and they cut it into 8 equal sized small cubes and they put those into a different sugar solution. Sorry, same sugar solution but a different container. So what they end up with is a container containing a big cube and a container with 8 small cubes in there. And then he recorded the mass, the weight, the mass of the cubes at different intervals. At the end of the investigation, they plotted a graph, and I'll be coming back to this in a second. So the first question says, describe the method the student would have used to obtain the results. Start after all the cubes of potato have been cut. Consider the variables they should have controlled. I'm not going to give you the answers here. I'm going to give you some things to think about. And I hope that you'll have a go at the question. And towards the end of the video, I'll remind you when we get there, but there is a mark scheme. So hopefully you can have a go at these questions, pause it before the mark scheme occurs, and then you can mark it yourself. So some things to just kind of think about. First off, the temperature will affect the speed at which osmosis can occur. So temperature is a factor. You've got to consider how that can be kept the same, how that can be controlled. Another one to try and think about is these cubes of potato have been in sugar solution, and solution adds mass. So how can you make sure that the cubes don't have extra sugar solution on the surface and therefore increasing the mass of the cube? How can you make sure that the time intervals are the same in each one? And finally, with one of the cubes, you cut it into 8 and you put the 8 pieces into some sugar solution. Now, if those 8 cubes are all stacked up, they're not really 8 cubes because the surface area, if 2 sides are touching, the surface area will decrease. So how can you make sure that you can have all 8 mini cubes spread out within the sugar solution? Okay, so just a few things to think about. What you saw in the investigation is that the potato cubes began to change mass. And you've got one of them that is just a big single cube and one of them that is 8 small cubes. The question here says, is the rate of osmosis different between the 2 cubes? Use an appropriate calculation to support your answer. I'm just going to flick back to the graph. It does kind of look like it, that they both kind of drop quickly in the first 0 to 40 minutes, and then they do both level off. So they do kind of look similar, but they do get further apart, so there's something in there. So it would suggest that the rate is different. I'm not certain, but I'm going to calculate it. Now again, I'm not going to give you the answers. I'm going to get you to think about how you would get the answer. And hopefully you can have a little go. And like I said, the mark scheme will be towards the end. So the first thing to try and think about is we've got 1 big cube and 8 smaller cubes. So you have to work out the surface area. So think, how do you work out the surface area of your 1 big cube? That's one little aspect. And then how do you work out the surface area of the 8 small cubes? So it's a bit of maths to work that out, but hopefully you can do that. That's one thing to think about. The question does say the rate of osmosis between 0 and 40. So you've got to get the starting point at 0 and what it finished at 40. and you've got to try and work out the difference. That's another bit. You've then got to use your surface area and the rate to try and work out, is there a difference? So I'm not going to do any more than that. I'm going to leave you those two things, a couple of calculations first to try and answer the question. So if you'd like to have a go at the question, pause the video now. Okay, so the maths is going to come up on the next slide. Please make sure you've had a go at it. Even if you're not sure and maths isn't your favourite thing, you've got to make sure you're always having a go. So have a go at the calculations. And here's the mark scheme. Okay, so you can see what we're looking for. You look in the comment section. These are examples of things you could have said. So, for example, a method of controlling the temperature. You could have had the idea of keeping the room temperature the same. You've got to be specific, not just the temperature the same, but the room temperature the same. You could have done this in a water bath to keep the temperature the same. A method of drying the cubes. So as long as it's something sensible, then as long as you dry the cubes, it's fine. So you could have gently dabbed them with a paper towel. You could, or you couldn't put them in the oven for 45 minutes. That's not realistic, but drying them with a paper towel is. The calculations. So first thing is to work out the surface area. You've then got to work out the difference in the rates. And then you're going to divide the two. You can divide the rate by the surface area. Okay, so you should have some calculations that are between those numbers, between 1.6 times 10 to the minus 5 and 1.8 times 10 to the minus 5, and 1.5 times 10 to the minus 5 and 1.6 times 10 to the minus 5. Okay, now these questions, they are tough. That's why I've done the video on this one. It's all about just read it carefully, break it down, take your time. Don't look at the mark scheme until you've had a go. When you've had a go and you've given it your best shot, that's the time to look at the mark scheme. And if you're still stuck, speak to your teacher and hopefully we can help you out. Okay, take care.